Everybody, welcome back to another fun and exciting geometry class. Today we'll be in lessons 5.10. This is kind of a big section here. So 5.10, 5.11, 5.12, 5.13. So we're going to do several lessons here together. None of them really teach anything like per se, like they don't have like examples and different things. But there is one very important concept in this section of problems, and that is Herron's formula. So let's go ahead and teach through that, and then we'll do an example with Herron's formula, and then you can just practice some of these other ones as you go. All right, so in your book on page 250, in lesson 5.10, if you look at question number 9, it says, prove that if A, B, and C represent the sides of a triangle and 2S equals A plus B plus C, then the area, and then it gives Herron's formula. Basically, the area of ABC equals the square root of S times S minus A times S minus B times S minus C. All right, so what they want you to do here is prove it, but they don't really want you to prove it in a way because they prove it. You just kind of walk through it with them. So if you'll look at that, you'll kind of look through number 9, and you'll see their steps as they delineate that out. We don't need to delineate that out. You can look at it. You can kind of understand a little bit of what they're doing. There's a lot of movement there. It's just algebraic movement of things. So you're going from the formula for finding the area of a triangle. Area is 1/2 of the base times the altitude, and then you work through it until you get Herron's formula. Well, it's pretty cool. Down there at the bottom of the page, it says that Herron was from Alexandria. And if you know anything about Alexandria, you probably know that that was in ancient times like a center for learning. There was a library there, a lot of learning going on in Alexandria. It was kind of like the epicenter, if you will, of learning during that time. Well, there was a man there named Herron of Alexandria, and he was a mathematician, and Herron developed this formula that we're looking at here. So pretty neat. This was during the time of Jesus, basically, during the 1st century. So kind of in that time frame, if you will, of when Jesus was here walking on the earth, this guy, Herron, was developing this formula. So what is it and how does it work? Well, it's a formula for finding the area of a triangle. You say, I thought we already had a formula for finding the area of a triangle. We do, but in that formula, we need the altitude. In Herron's formula, he says we don't need the altitude. We can use other things to figure it out. And he says basically we need the sides. If we know the length of the sides, we can figure out the area of the triangle. We don't even need to figure out the altitude. So here's the way that looks. In his formula, the letter S equals A plus B plus C divided by 2. Another thing that you're going to need quite often in this formula is you're going to need 2S. And 2S just equals A plus B plus C. Basically all I did was multiplied both sides by 2 right here, right? So, in doing that, that's going to cancel, and you're left with 2S equals A plus B plus C. That is simple math, and you should be able to do that, but it is something that you will probably need at times as you go through this, as you try to figure this out. But the formula itself doesn't need the 2S. The formula itself just needs the S. So when we can figure out S, then we can plug it in everywhere that it goes into the formula. And then if we know A, right, A plugs in. And if we know B, B plugs in. And if we know C, C plugs in. So if we know A, B, and C, we'll be able to figure out S, and we'll be able to figure out Herron's formula by just using A, B, and C. So let's practice it. If you look at page 252, so go ahead and turn the page. And one thing that I would do right there with Herron's formula on page 250, I would highlight that. In my book, it's highlighted. So that way I know, hey, it's not in a teaching section, it's not a theorem here, but this is something that I do need to know. So highlight that, put a circle around it, mark that in your book, write it in your notes, something. All right, so turn the page over to 252. Look at exercise 5.13. and look at number 1. In number 1, it says find the area of an isosceles triangle if the base is 10 and one leg is 13. Couple key things there is, first of all, it's an isosceles triangle. What do we know about isosceles triangles? Well, the legs are equal in isosceles triangles. So when it says one leg is 13, that means that both legs are 13 because it's an isosceles triangle. So let's go ahead and draw out an isosceles triangle. So we'll go ahead and put them right there, and we'll go ahead and mark it up. So the base is 10, and the legs are 13 each, and these are all in inches. Okay, now, before we learn Herron's theorem, we have a way to solve this, right? We could put our altitude in here, so we could say, okay, yep, our altitude goes from here down, and we could figure that out, because now we know that, okay, both of these are 5 and now we know that both of these are 5 and 5, right? You just split the 10 because that bisects it. We've done this before. So now we have to use the Pythagorean theorem right here to be able to figure out what our altitude is. And if you think about it, think about what Herron is doing right here. Herron is actually using that exact same process, because if you look here, he's using the Pythagorean theorem, isn't he? He's using the a squared, b squared, and c squared, and then he's square rooting it. So he's doing the same thing. The same concept is going on there, but it's going to look just a little bit different because he's really kind of delineated the Pythagorean theorem. He's delineated the area formula for a triangle, and he's kind of put them together into a way that we can use that in order to solve our area for our triangle. So we don't have to figure the altitude out in this one. We already have everything that we need. So let's call this one A, we'll call this one B, and we'll call this one C. Okay, we're just randomly calling it that. So let's write it out here. So A equals 13, B equals 13, and C equals 10. And so then we need to find S. What does S equal? And that's the one that we don't have. So go back up here to your little formula. What does S equal? S equals A plus B plus C divided by 2. So let's go ahead and do that. So 13 plus 13 plus 10 divided by 2. 13 plus 13 is 26, plus 10 is 36. 36 divided by 2 is 18. So S is going to equal 18. Now what do? Now we go ahead and we just start plugging in, because we know our formula and now we know our A, B, C, and S. So let's just go ahead and plug into it. So there's the formula right there. I'll just plug into it right here and we'll work it from right here. So S is 18. So we have 18 times 18 minus A was 13. And then that's times 18 minus 13 again, and then that's times 18 minus 10, because that was the side that we said was C. All right, so then we just gotta, do it again. So 18, and this is all square root, don't forget about that, times 18 minus 13 is going to give me 5, times 18 minus 13 again is going to give me 5, times 8, and that's all square rooted. So now I'll just grab my calculator here. It'll be a little bit faster. I could kind of plug the whole thing in right here, but I'll just do it piece by piece. So I'll do 18 times 5 times 5 times 8 equals 3,600. And you should be able to kind of figure out the square root of that. Obviously, the square root of 36 is 6. And then the extra zeros, maybe you can figure that out, square root of 100. I would break this down into the square root of 6, basically, and of 100, which is 10. So 6 times 10 is going to be 60. But you can obviously use your calculator as well. So hit your square root key and then do 3,600, and that's going to equal 60. So either way you do it there, if you do it in your mind, that's fine. But that's going to equal 60. In other words, our area of this triangle is going to equal 60. So you would do T equals 60. And that would be what? Units squared, so that would be inches squared. Now, again, there's other ways that you could do that. You could put that into, you could figure out what the altitude is, and you could put that into the other formula, but you will end up coming up to the same conclusion that the area of that triangle is 60 inches squared. Pretty cool formula. But you really definitely need to know that. That's one of those ones where it's kind of tucked into the exercises, but you do need to know it. So, my challenge to you there is to, go through the rest of those. That's really the one that like stuck out to me. Like, if you don't know that, then you're going to struggle with some of the other ones. It has some proofs in there, so go through the proofs and make sure that you can prove some of those things. Some of the most important ones for you to do are on page 510, and numbers 2, 3, 4, and 5 all have like an asterisk next to them. Those ones are the ones that you really need to do. Those ones are the ones that are very important for you to make sure that you get those so that you understand future concepts. 7, 8, and 9 also have, and 10 actually also has the asterisk. So, those are ones that you're really going to want to pay some attention to. There's other ones through it. But yeah, work some of those problems out so that you can understand these, because you're going to see these types of problems coming up on your tests in the future. All right, that's all I've got for you in this lesson, a little bit shorter. Hope you enjoyed that. Hope you learned something there. If you missed anything about Herron's formula, slide it back, watch it again. We'll see you later. Have a good one. Bye-bye.